we have a more general work energy theorem. This is a trapezoid, and its slope is A, and its area is delta x. Its initial height is V naught, and its final height is V. We want to change the shape, but we want to keep the initial height and the final height. But we want the slope to be 1. Then what will happen to the area? Since we keep the height, we change the base only. Base is increasing by the factor of the slope A. Therefore, the new area is slope times the area delta x. Now the new slope is 1. We intentionally keep this area to 1. There is another way to calculate the same area, A times delta x, using the two right triangles. Notice that there are two triangles, the big right triangle and then small right triangle. The area of the big right triangle is 1/2 V squared. And the small right triangle is 1/2 V naught squared. Notice that they are isosceles right triangle because the slope is 1. We multiply every term by an arbitrary number, m. This is the meaning of a work energy theorem in geometry. We are going to change the names in physics. We keep the same formula, same equation, but we simply change the names. Let's just say m is mass in physics. Then left-hand side expression becomes mass times A, acceleration, delta x, displacement in physics. So mass times acceleration, that is a force. And delta x, that's a displacement. Right-hand side of 1/2 mv squared. M is a mass, and v is velocity in physics. Therefore, 1/2 mv squared, it is a kinetic energy. So left-hand side, force times the displacement, that is a work. And right-hand side, the 1/2 mv squared, that is kinetic energy. So this simple equation is telling us that work is equal to the final kinetic energy minus initial kinetic energy. So in summary, work is equal to the final kinetic energy minus initial kinetic energy, or simply speaking, change in kinetic energy. That is the true meaning of work energy theorem in physics and in geometry.